Rab explains it all. Math, chem, physics never fall. Subscribe and learn. Ace every test, so Rab explains it best.
Hi everyone, I hope you are doing well. Welcome to this video and welcome to my channel. In this video, we are going to learn how to calculate GCF of algebraic terms. It means in addition to having numbers as coefficients, we have variables with different powers. Before we start solving examples, it's important to get familiar with the formula that we are going to use for calculating GCF, which is equal to common factors between all of the terms with the minimum power. I know that at the beginning it may be a little bit complicated for you, but I assure you that at the end of this video, you are going to get this formula. We are going to learn that through examples. Let's solve the first example with each other. As you can see, we want to calculate GCF of two terms. This is the first term and this is the second term. So I'm going to call it 1 and I'm going to call it 2. First, we are going to write factors of the number part. This is the number part of the first term. This is the number part of the second term. So let's start with 30. I'm going to write prime factors of 30. If you don't know how to calculate prime factorization of a number, I strongly suggest you to watch that video first. I'm going to put the link in the description. But let's have a recap here. Do I know any prime number that I can divide 30 to that? Yes, of course, it is 2. If I divide 30 by 2, the answer will be 15. Do I know any prime number that I can divide 15 to that? Yes, of course, it is 3. If I do that, the answer will be 5. Again, do I know any prime number that I can divide 5 by that? Yes, 5. 5 divided by 5 will be 1, and when I reach 1, I must stop. Let's go for the second one, which is 12. Do I know any prime number? Yes, 2. It is going to be 6. Then 2 again. It's going to be 3. And I can divide it by 3. It's going to be 1. When I reach 1, I must stop the process. So I can write the first term as you can see, I need to write the first part as prime factors. So as you can see, I can write 30 as 2 times 3 times 5. Okay, it was the number part. What should I do with the variable part? I must write it without changing that. So I'm going to write it exactly x to the power of 2, y, z. As you can see, I didn't change the variable part. So let's go for the second one. As you can see, I have two 2's here and I have one 3. So I can write 2 to the power of 2 times 3. And I should not change the variable part. So I must write x, y to the power of 3. Now let's calculate GCF with each other. What should I do for calculating GCF? I must find common factors between these two terms. So as you can see, 2 is common between them. 3 is common between them. 5. Is 5 common between them? No, as you can see, I have 5 in the first term and I do not have 5 in the second term. So I have nothing to do with the 5. X is common between them. Y is common between them. And Z, is it common between them? No, I have it in the first term and I do not have it in the second term. So I have nothing to do with that. And common factors must come with the least power. Look at the 2. Here I have 2 to the power of 2. Here I have 2 to the power of 1. Which one should I consider least power? So I must just write 2 because between 2 and 1, 1 is the least power. Look at 3. Here the power of 3 is 1. Here the power of 3 is 1 as well. So the least power will be 3. Here the power of x is 2. Here the power of x is 1. So I must consider the lowest power. It means x to the power of 1. Here the power of y is 3. Here the power of y is 1. So I must consider the least power, y. So GCF will be equal to 2 times 3 is 6 xy. This is the GCF of this example. Let's solve the next example with each other. Here we have 3 terms. So as you can see, I'm going to call it 1, 2, and the last one will be 3. Let's start with the numbers, coefficients, and write prime factors of them. Again, I'm telling you, if you don't know how to write prime factors of a number, I strongly suggest you to watch that video first. I'm going to put the link in the description. Do I know any prime number? Yes, 2. It's going to be 10. Again, 2. It's going to be 5. 5. 1. When I reach 1, I must stop. Let's go for the 8. I'm going to write 2. It's going to be 4. 2. It's going to be 2. 2 again. It's going to be 1. And 25, which is obvious, but I'm going to write it anyway. 5. 5 divided by 5. 1. I must stop. So I can write the first term as you can see. I have 2 2's and 1 5. So 2 to the power of 2 times 5. And I should not change the variable part. So a to the power of 2 b. Second one, 8. As you can see, I have 3 2's. So I can write 2 to the power of 3 b c. Third one, as you can see, I have 2 5's. So 5 to the power of 2 a 2 c 2. So GCF will be equal to, okay, let's find the terms which are common between all of them. So they must be common between all of them. Look, 2 is common between the first term and second term. But do we have any 2 in the third term? No, as you can see, there is no 2 in the third term. So we should not consider 2 because it must be common between all of the terms. Here I have 5 in the first term and I have 5 in the last term. Do I have any 5 in the second term? No, so I should not consider the 5. Look at the a. I have a in the first term and I have a in the last term. Do I have any a in the second term? No, so I should not consider a. Do I have b in the first term and in the second term? Do I have any b in the last term? No, so I should not consider b. I have c in the second term and in the last term. Do I have any c in the first term? No, so it is not common between all of them, so I should not consider that. As you can see, I cannot find any common factors between all of the terms, so GCF will be equal to 1, and this is the correct answer of this example. When we reach to this part, sometimes the students ask me, teacher, are we allowed to calculate GCF of number parts with factor listing? My answer is yes, you are allowed to use factor listing, but I do not suggest you at all. Why? Because the possibility of making mistake is really high and it is really time consuming. So the best method for calculating GCF of number parts is prime factorization method. Let's solve the next one. Here we have 3 terms as well. This is going to be the first term, second term, and last term. We are going to call it 1, 2, 3. So let's start with the number part, 16. I can divide it by 2, 8, 2, 4, 2, 2, 2, 1. When I reach 1, I must stop. 24. I can start with 2. I'm going to have 12, 2, 6, 2, 3, 3, 1. 30. I can start with 2, 15, 3, 5, 5, 1. So I can write the first term as You can see here, I have 4 2's, so 2 to the power of 4. I should not change the variable part. M2, N4. Let's solve the Let's write for second one. As you can see, I have 3 2's and I have 1 3. So 2 to the power of 3 times 3. And I should not change the variable part. M4, N. Third one, I can write it as 2 times 3 times 5. And I should not change the variable part. M3, N2, P. So GCF is equal to, look, 2 is common between first one, second one, and third one. So 2 is common between all of them. Now we can consider that. With which power? With the least power. Here the power of 2 is 4. Here the power of 2 is 3. Here the power of 2 is 1. So least power is 2. Here we do not have any 3, but here we have 3 and here we have 3 as well. But it is not common between all of them because we do not have it in the first term. So we should not consider that. Here we have 5, but in other terms we do not have 5. So we should not consider that. But here we have M, here we have M, here we have M. So M is common between all of them and it must come with the least power. What is the least power of M between all of them? It is 2. So 2, M to the power of 2. And here we have N, N, and N. So it is common between all of them, but what is the least power? As you can see, the least power of N is 1. What about P? As you can see, we have P only in the last term, so we should not consider that. So it's going to be GCF of this question. Here you can find more examples and I strongly suggest you to solve them at home. If you have any question or if you wanted to share your answer, please feel free and write them in the comment box. I will try to answer them as soon as it was possible for me. Thank you for watching this video.